Hello, good evening, everyone. Welcome again to another episode of Azure Community Live. This is our fifth episode, and I'm really happy to have this special guest here this week, Mark Fussell. Mark, welcome to the show. It's
It's
an
fantastic
honor
to
to
be
have
here.
you.
Thank you for having me. It's fantastic to be here. I'm looking forward to talking to you today about distributed application runtime.
Yeah, great. Um, so, um, yeah, DAPR. I've played with it quite a bit myself already. I'm really enthusiastic about it. So really curious what you will explain more to us, and especially for the people who haven't tried it. Hopefully, you can get them enthusiastic about this as well. Uh, well, with no further ado, let's just go to the content. I will give you the screen. If you share your screen, would be good.
Perfect. Okay.
Let's go to the slides and then let's get going. I'll give you the screen right now.
Perfect. I'm sharing my screen. Can you see this intro?
Yeah.
Great. So my name's Mark Fussell. I'm a program manager that works for Microsoft. Today I'm going to spend at least a good hour on distributed application runtime, otherwise known as DAPR. We released DAPR at October last year, and there was a bunch of news articles about the launch. There was an open post blog that we had around all of this, and it kind of generated a bunch of noise around this. And the goal of DAPR effectively is how is it that we can help you easily build event-driven distributed applications. You can go to dapr.io, where it kind of gives you a little bit of an overview of it and helps you to go to getting started. And from there, you can sort of download the script. But I'll show you what that looks like. But we're pretty excited about this. The goals of DAPR sort of address developer sentiment of how is it I build these portable, event-driven, microservice-based applications that I can build both locally, but run it across different platforms as well. So if you look at the state of enterprise developers today, more and more developers are being asked to build scalable, resilient microservices-based applications. Sometimes this is referred to as sort of building cloud-native applications. A common target for this platform is targeting things like Kubernetes in its different forms, including AKS in Azure or GKE in Google. But there are other platforms as well that people build upon, including Service Fabric and Docker Swarm, and if you stretch back to days, other ones called like Mesosphere and things. Increasingly, developers have to write many different languages. It's more about what's the right tool for the job. If I want to use a particular framework, or if I want to use a particular language, I should be empowered to use the thing that I'm using and not be forced into a particular direction that I'm not interested in kind of going down. Increasingly as well, actually not increasingly, typically you always have code that you want to bring and migrate. It's a lucky developer who has code that's brand new from scratch. You usually have some business code that you have that's running on premise today, and you want to move into a service, or just historical code that you want to make sure that you want to take advantage of. And we found generally that through our experience at Microsoft, the concept of having functions and actors, I'll go into these a little bit more, sort of powerful probing models that we want to encourage developers to use when they start to build these microservices applications. So a typical application may look something like this. This is kind of purely just fictitious. It's an application that consists of a front end. It's a shopping cart like application that has an inventory service and has an emailing service. But the important thing is that there are some services that are stateful, that contain state associated with them, like the card service here. Some that are stateless, that just sends like an email service. And, they don't track any particular data. They can be restarted. And invariably, of course, you work with external systems. You have to absorb events, calls from users from web-based APIs, and integrate with things like queues or databases. So polyglot applications with different frameworks, different languages, developed as microservice architectures, where the benefits of that allow you to have composability, upgradability, and scale out, are the direction that you have to use in order to build services. But I mean, there are a few things that we find that inspired DAPR especially how we started building a lot of microservices at Microsoft, and also what we've seen with all our customers build. One is one I mentioned already, is sort of migrating existing code. You want to be able to incrementally take existing code. But also programming models that we found were sort of had very narrow scope, or tended to only provide a certain set of features, or only targeted particular platforms. So, for example, Service Fabric is a great platform for building applications and microservices services on top of, but the application models there are deeply embedded into Service Fabric runtime itself, and you can't take the actors out there and run them on other platforms. Equally, when you look at things like functions, Azure Functions, it's great for doing stateless workloads, but it doesn't have any concept of state. So I can't do stateful long-running functions. And when I look at frameworks like ASP.NET Core, they're great for writing web applications or many web application frameworks. But again, they don't have the concept of being able to do messaging between my services or PubSub. So what we found is that we wanted to empower developers to take their frameworks and give them superpower capabilities so they could bring additional capabilities to the framework of their choice and not have to wait on a particular framework owner or designer to bring them for you. And so that's exactly the approach that DAPR does. It has this concept of microservices building blocks with a sidecar architecture that runs on the cloud and the edge. So let me dive into each of those and see what they actually mean. First, and most importantly, as you start to design microservice applications, this concept of a sidecar architecture is becoming predominant. You see it in things like Istio as a sidecar architecture for networking. You see people build sidecar architectures for getting security credentials. And so this approach now that I can call over a local HTTP or a gRPC endpoint to provide capabilities to my application is a common design pattern. And so effectively, if you look at the examples over here, DAPR provides a set of these building blocks, and we picked out the most common building blocks that we thought that you needed to build distributed applications with, things like service-to-service invocation. How is it I discover another service? And provided consistent local calls with a named API that you can use to take advantage of them. So, for example, if I want to call onto the My App service that's running and call a new order method inside it all, I can do this local URL call like this. I will call onto that endpoint and the new order method inside it all, providing a set of data to it all. Equally, if I wanted to save state from my application, I could call onto a particular state management API and save state. So these building blocks, coupled with this API type model running as a sidecar, is key to providing the flexibility and the capabilities for you to empower yourselves to bring superpower capabilities to any one of your frameworks or languages of your choice. We'll dive into each one of these and what they look like. The other key thing that you'll also see is that DAPR very much thinks around sort of a component model. So in any one of these different building block APIs, these themselves are broken down into a set of components that you can plug in. So for example, state management has state components that make it pluggable for you storing key value state into any backing store. And when we launched DAPR back in October, we only had 3 state stores. We had Cosmos DB, Redis, and another one, I think Cassandra. And since then, the community have added about another 15 state stores, including Couchbase, Zookeeper, Google Firestore, Amazon DynamoDB, that allow you to plug in dynamically on top of this API and change where your state is recorded, your state is saved, without you having to change any of your code. So that key flexibility, if I don't have to change my code, but I have flexibility over where my state is managed from any language, makes DAPR very acceptable and can be plugged into your frameworks. It can be integrated easily with you. So this sidecar architecture has many different languages on top of it all. I'll show you what these look like. And when you run DAPR in your local machine, you end up getting a DAPR instance like this, which runs on a per application instance basis. So application A, this application here consists of service A and service code B. Each launch their own DAPR instance as a sidecar. They talk over the DAPR API. Again, this could be HTTP or gRPC. And then DAPR itself communicates between its instances for example, publish and subscribe or message invocation. And at the same time, external triggers both input and output, can be triggered on your actual application code by DAPR monitoring external events such as a Kafka queue on your behalf and signaling it to your application. Equally, when your application chooses to store state, the DAPR API will push it into the state store of your choice. So this is a self-hosted developer model, it looks like. If you take the same thing and key to DAPR, it'll run on multiple different platforms. So as we go forward, you'll see it start to run on IoT Edge. You'll see it run on our Microsoft other Edge devices. We've integrated with Kubernetes, and of course, there'll be other platforms as well, including things like Service Fabric. But if I look at Kubernetes, our first-class integration here consists of the fact that we have CRDs inside Kubernetes. One of them which is a sidecar injector. So when you annotate your application to say it's DAPR enabled, when the pod comes up, the sidecar injector figures out that your application requires DAPR as a sidecar and will launch it on your behalf. And then other system services that run inside DAPR monitor external component bindings updates that get pushed into your application to say if I change my bindings, to indicate to my application code where to save those. And this placement service is used for actor placement determining. We'll dive more into that about what actors look like. So this is what it looks like from a Kubernetes deployment, from a first-class experience. And this means now that when I write code locally and deploy it into my Kubernetes cluster, I don't have to change my code in any way. So as I mentioned, different frameworks that we have that are, or different languages are DAPR enabled. We call onto DAPR set of building blocks, and then these can be deployed on different sets of infrastructure. If we look through these building blocks here, we've talked about service-to-service invocation, which is calling from one service to another, saving state through key value pairs, publishing messages from one application to another through a topic and subscribe mechanism, having triggers on external events, such as a message from a Kafka queue or writing out to a queue. Actors allows me to have state and data co-located and provide a very efficient programming model for certain applications. Tracing allows me to see calls between my services, and you can build in and plug your own extensible building blocks on top of all this. Actually, I've just gone through all of that. So that's just the same thing I just ran through, but a little bit more detail around these. So these building blocks are key because they provide the APIs on top of that, and you'll see more of these coming. In fact, we're working on even one now, which is a security building block, where effectively we want it for you to be able to easily be able to pull keys from any state store and be able to use them inside your application. So let's look at a couple of examples, and then we'll dive into some code. So for example, let's show me one first about what the state management API looks like. So if I'm using my application here called My App, and I want to store some state, and inside this state, I put some key value pairs like this. So I want to store the state of the weapon for the Death Star on the planet Tatooine. I store some key value pairs calling onto DAPR, and then DAPR's pluggable component model here allows me to push into the state store of my choice. Equally, I can call onto this state store, providing the key of my request. This will get back the particular key and recover my data. So this abstraction layer allows me to generally store key value pairs into any state of my choice. So let me show you that. Before I dive into showing you the demo, it's worth showing you that if I go to GitHub here, this is the DAPR repo. Inside the DAPR repo, you'll see that this is the DAPR runtime, docs, and we have a CLI. And this is where the component model plugs into DAPR. So for example, the state pluggable stores are in the state components repo. And this is where we've had huge numbers of community contribution. And you can see the number of different types of state stores. So underneath Azure itself, there's Cosmos Daemon table storage, but there's state stores for Zookeeper and Hazelcast and Cassandra and Aerospike that just got added recently. So all of these are different ways that you can plug in and store your data. So let's show an example of what that looks like, because I think this will help solidify this. So can everyone see my here, which is VS Code, yes?
Yeah, we can see your screen.
Okay. So this is a very simple application. It's a Python application. It just launches Python as a web app, and it calculates pi. So this is the calculation for pi. I'm not going to go into what the calculation for pi is itself, but it just calculates pi to a certain number of decimal places. I can control the number of decimal places it gets written. If you want to get started with DAPR, by the way, it's very easy to run a script that puts DAPR onto your machine, and then you have a CLI, and you can run the CLI here. This is the DAPR CLI, and inside here you can do DAPR init, and it will install and configure DAPR into your machine. What that does as part of DAPR init is it actually installs a local state store. It installs a Redis state store that you can use here for just local development purposes. So that's kind of the by default local development state store. You can actually also inside VS, we have dev container plugins. So if you want to pull down DAPR as a whole dev container, that's been developed by the Visual Studio Code team for us, and DAPR running inside a container environment, you can do that. But by default, with this experience, if I do DAPR init on my machine, it'll install Redis as a container, and it'll install DAPR executables, and then I can do DAPR commands in terms of running this particular application. So I could just do a Python app.py to run this, but the other way I can run this particular application is I can use the DAPR CLI down here called DAPR run, where I just launch my Python application here, this app.py, and then I give it a unique name that I want to run it underneath. So this is the app ID here, in this particular case called PyCalc. So if I just run this, DAPR launches, it runs my application, it generates the value of pi to a certain number of decimal places, and then it stops. And you can see that if I run this, and if I kill it halfway through, it's a stateless application. It got to 175 decimal places. If I run it again, it'll start the calculation over again, and it will recalculate it. So, this is a classic stateless application. Every time it comes up, it just reruns all of its state again and recalculates the value of pi. So what I'm going to do is I'm going to DAPR enable this particular Python application in order for it to keep state. So what I've gone and done here is I've got two methods here, one called getState and one called saveState. Let's look at the saveState first. So as I showed you in the slides, by simply calling on to the state API here with a set of key values here, this is the key called PyState, and here's its value. I can do a post message onto through to this particular endpoint here, and now I can just store a key value data structure into my state store of choice. That state store here is that Redis state store, and this is how it's underneath my components here in Pluggable. So here, this is the definition of the Redis state store that I'm going to plug into, and we'll show how I'm going to show you later how I can change this state store. I'm going to change it to Cosmos DB, but here I can set up the components, and this state store here is the name of the state store that I'm going to write my data to. So returning back to the code, that's my save state, just calling onto this URL. And equally, if I want to recover my state, I call on to the URL endpoint here, this time getting back the key called PyState. It recovers the state, it does some checks on it all, and returns the state back for me. So, I can just write these two simple methods, calling onto my local endpoint, and then DAPR does all the hard work of figuring out where to store that state. So let me go down to my code. Let me take advantage of those. I'm going to call the getState API each time. I'm going to call the saveState API here after I've saved my state and done a calculation here. And so let me go back down to my run command here. I'm going to still do DAPR run, and now I'm going to kick off and run it. So this time it's saving all the state into Redis state store. So if I kill it, it got to 139 here. Now if I rerun the same application again, it'll recover the state, and it'll pick up the state from point 139 here, and you'll see that it carried on doing the calculation from 139. There's a bit of a bug here, that writes 138 first, but it covers the state and writes it all out at the end here. And if I now go into my Redis Explorer, my local state store here, you'll actually see that here's the data that gets stored inside here, for the state for that and the value of pi that gets written. So super easy now for me to make my application that was stateless become stateful. But say I've decided now that my state store Redis was great for testing locally, but I wanted to make it, a more resilient state store, and I wanted to change it all. So if I go in here and I can actually set up a new state store. In this particular case, I'm just going to change the state store to be Cosmos DB. So now I've simply switched over and provided the credentials for this. By the way, all these credentials here, although I've put them in line here, you can actually put them all as credentials that are stored in any Key Vault or inside a Kubernetes cluster environment, so that the keys aren't actually in your code, and you can load them from externalized stores. So there's deep integration there for putting down externalized secrets. So now if I go back here and now rerun this again, I'm going to run the same app. Now it's going to store the state not inside Redis, but it's going to store the state. Actually, I have to redo this calculation. Let me just go back here. Let me just change because I already have one of these stored. So let me just change. It just retrieved the state. So I want you to show the calculation. So let me run this. It'll now calculate pi this time. This time it's a little slower because it's writing over to a network. So while it's doing that, let me switch over to Azure here. Let me just refresh my session. And once this gets refreshed, you'll see that this continues to write out. This has written out the value now of pi to 410 precision databases. At decimal points, if I now go and look at my Cosmos DB database, I go into the Data Explorer. If I open up my pi database here and I look at items inside it all, you'll see that the value of the pi calc state here, which was the value for 110 decimal places, which should have a value down here for 410 decimal places, has now been written instead of to Redis, is now written to Cosmos DB. So this is super easy. I didn't change any of my code. I let DAPR do all the hard work of storing the state inside here. So now, if I just run this again, it won't calculate the state, it'll just retrieve it. And as you saw before inside here, it just pulls back the state that's already stored inside my Cosmos DB table, making my application that was stateless fully stateful by simply calling onto these local APIs. So hopefully that's going to give you a flavor of the power that you get from the componentization with some of the capabilities inside here of DAPR. If we look at how you can take this further, I'm going to switch now to a set of other samples here. So this is another Visual VS Code instance I have running. And we have a set of samples that you can go, if you go to our repo inside here, if you go back to the DAPR repo, you'll see there's a whole set of samples and getting started guide here for helping you build applications that are everything from a local hello world to running on sort of Kubernetes. So I'm going to show a few of these because these enable you to kind of understand the rest of the capabilities that DAPR provides. So in this hello world one, in the same that we saw before, this also is this time I've got a node application here that's running. And you'll see that I have a publish method here. And I have, this node application, wrong one. This node application. This node application. So I have an order method here where I'm calling on, and I'm setting a new order here in the same way that I had before. I'm saving some order data here, and I'm retrieving an order. So I can pull back a particular order from my application, and I'm saving in my state store, just like I had before. And this time I'm using Redis as my local state store, but this time I've integrated it with a node application and called onto the state stores there. But what I want to show you now is the fact that I can do cross-machine method invocation with DAPR. And just to kind of start this off simple, I can fire up a tool that allows me, like Postman, in order to post messages into this application. So you'll see I'm going to call onto this localhost invoke method endpoint here. So this time I'm using the invoke capabilities of DAPR to invoke a method inside here. So if I go back here and if I go, I think I had one of these running already. So inside here, I'm going to do a DAPR run command, this time launching a node application, running under a particular port, and here's a node application. So if I run this, DAPR now launches this application that's running. I can actually go off to any CLI like this and do DAPR list, and you'll see that here is the instances of my application I've got running. I've still got that PyCalc running, and I've got this node app running. You see, so now I've got two apps running on my local machine. I'll kill off the Pi app one in a moment. They're both bound to different ports. These are the ports that DAPR is listening on for them, and this is the application port that my node application is listening on here. But the important thing here is just to show how I do invoke. I can post to this 3500, which is the DAPR port, to invoke messages on side here. So here I am. I'm going to poke a message onto the method on my node application that's running. This is the node app here that's running, and I'm going to call a new order method. So if I just change this value inside here and I call it 3500 and I do a post, you'll see now that I've called onto the new order method inside here, which is just a post endpoint that I exposed. It's as simple as that. DAPR does all the hard work of doing the request, pushing it through, and calling onto this particular endpoint inside here. And if I actually, in this particular case, given it's persisted, I can actually go and do a get on the order endpoint here, this time through DAPR. And if I call this, I'll get back the data I just saved inside here, which is the order, particular order ID. What's good about this, of course, is I can call this from other applications. So here I have my Python application that's running. And instead of using Postman to do that, I can have another app here, and in the same way, create the same sort of URL, invoke the node app method here called new order, and just push the data inside here. And if I were to run this, you'd see all my orders generating, and the Python application here would be pushing new orders into my node application. So it's as simple as calling that between two different services that are running. Where those services are running, it doesn't matter. It doesn't care to me. They could be on the same machine, different machines. As long as they're all inside the same environment, I can run them anywhere. Now, the great thing is I can take this code here, and I can run it inside a different environment without any code changes. So here I have the same application we had before, but I can take this now and I can run this inside my Kubernetes cluster. So I'm just going to kill this application off here at the moment. And now I'm just going to switch over to a different terminal. You'll see here now that what I've gone and done is all it takes for me to deploy these applications to a Kubernetes cluster is to create a Kubernetes deployment file here. So here's a Kubernetes deployment. This describes how my node application is going to get deployed. This is the container image that's going to get deployed for it. So I built that piece of code into a container image. And then all I have to do now is annotate inside the deployment through some metadata annotations here that I'm going to enable this application to be DAPR enabled. It's going to launch under this particular node ID, just like we saw inside the CLI command on this particular port. And I'm actually also going to enable tracing on this. So here I am. I can do the same thing with my Python application I just showed you. I can launch the Python application as well. And so by simply going into my deploy here, you'll see that I can actually do a K, which is kubectl, apply -f on the node definition like this, and I can deploy this into my Kubernetes cluster. So if I do look at what's running inside my Kubernetes cluster here, you'll see, as I showed you in the slide, DAPR's first-class integration with providing a set of runtime capabilities here that tells it how to inject DAPR as a sidecar running from my application. And here's my Node and Python application up and running. Node code changes. I just deployed them into a different environment here now. And so actually, if I go and look at this particular here, if I do k get services, you'll see that I actually have a service exposed on this particular node application here. So I actually can go and get this. If I go up into Visual, into a browser here and hit the order endpoint method, you'll see that this is the order method here that's being called from by the Python application, updating the order inside that node application on a continuous basis. So the code that we saw here, the same code inside this Python application here that's just pushing orders, is now just this Python application here that's been deployed, pushing orders into my node application. So no code changes, just to deploy it to a Kubernetes environment. And this now here, the invoke method takes advantage of the platform. So the invoke method is actually taking advantage of the Kubernetes DNS resolution service in order to call between these two services. And you'll see that here's the DAPR sidecar instances that are launched running next to those node applications. So pretty cool, in order for me to be able to say, now I can build a distributed application and easily call between them with this sort of URL format around these things. If you look at taking a little bit further inside the Kubernetes environment, we actually built this thing here called a DAPR Dashboard. And the dashboard allows me to kind of have a little view about what's happening. So I can actually go and just if I go down here, if I just do a port forward here on the DAPR dashboard to port 80 and run this, so this little dashboard allows me to have some views. And if I now go up here and do look at port localhost 8080, we're going to spend a lot more time building this all out, but this just gives me a view of the instances of my DAPR instances that are running here for each one of my applications. You'll see that this is the applications you've just seen, a Node app and a Python app. I can go and look at their logs inside here about what's happening. You'll see that I have other DAPR applications deployed inside here, and I can go and see the components that have been deployed here. This is this local Redis state store. I also have Zipkin deployed for me to be able to do tracing between each one of my DAPR sidecar instances to be able to give me a call visualization and metrics between my DAPR instances, so I can see performance metrics. I can see the call graph of how my applications are running. So this is a fun little dashboard inside here.
Hey Mark, a small question. The dashboard, is that something new in 0.4, or I haven't seen it before?
This was new, but this is actually in our repo here. So if you go to our repo inside here, we put a dashboard inside here. This is a new repo called Dashboard. We just started to build this out. If you go inside here, you can build it as a container, and we're going to start deploying this by default not in our 4.0 release, but after that. But yeah, feel free to dive in, contribute to this. We'd love to make this more feature rich.
I'll have a look. Looks great.
Yes, it's great. This is fun. It needs to have more things inside here. So there are things that we want to be able to see inside here, like configuration files and other capabilities. So we just started this off. What I've also done in this cluster that I have here is I'll show you some diagnostics capabilities. So you see that I've actually deployed Zipkin inside there. So let me show you what that looks like. But in order to show you that, we can take this whole concept of distributed applications a lot further. We have this example here called distributed calculator, where it builds each one of the calculator operations. You'll see here's this distributed calculator. Each one of these operations here, the divide, multiply, minus, and add, is its own little microservice application, each one written in a different language. So this just kind of makes it a little bit more kind of unique to show that, how you can take it to an extreme level of, how you build your microservices applications. So for example, my divide application is written as a node application inside here. And each one of these is deployed inside my Kubernetes cluster in the same way. I've enabled tracing on these things. If you actually go and look at the client for this, there's a React front-end calculator. You'll see that, calling onto the invoke and the state method between them all, it's as simple as building out, the invoke, the calculator add method inside here, calling on the add app, add method inside here. So this React service that runs here that the React front end calls onto, simply just calls onto each one of these services that are deployed inside my cluster. So you'll see these inside here. So if I do get, oops, I do get pods down here. Oops, you'll see that I have the divide application, node application, subtract application, add application, all deployed running inside my cluster. And I've turned on tracing for each one of these, so that they're pumping all the tracing information between them all. So what I can do now is if I just do port forward again in this particular case, this time I'm going to port forward my Zipkin endpoint here to see all my tracing information. So now what I can do is if I go back up here to Zipkin and I just refresh this on my local endpoint, you'll see that these two applications here, the node application and this Python application here, I can see all the trace information from them all. So this shows that the calculator front end here, as I do calls onto this that is running. So here's the calculator front end. You can actually see the operations inside here. So if I do 9 plus 3 inside here, you can see the operations calling each one of those individual services times by 9. You can see that it's 81. If I kill this off and open up a new browser, you see that it's a persistent stateful application. So I haven't lost any of my state, but I can see all those particular calls, to the add application that's happening here, endpoint, and I can see the traces that happens for those particular for that particular add operation there. You'll just see that I did one there at 11:36 standard time inside here, and you can sort of dive into this and see the detail of the trace between my front end application down through the add application, and how including here's the operation of the data. So this is pretty cool, very rich data you get out of Zipkin, but you can plug any of the tracing exporters inside here. I don't have one set up now, but you can send this data into App Insights and to Azure Monitor, so you can see the app graph inside there for the same application. You can push it into Datadog or any of the other sort of providers around these things. So we think this is pretty cool. We haven't got all our metrics inside here yet in terms of between calls between the services, but that's something we'll be working on in the next release. But this ability to plug in different state providers, exporting providers, goes back to the whole component model of DAPR here again, where when I go to DAPR here and I go back to the components contribute here, you see that there's this thing called exporters here. At the moment, these exporters all use open sensors as the format. We'll be also supporting open telemetry, but you'll see that there's just 3 exporters here at the moment. One that does it to string, this one does it to Azure Monitor, and this one does it to Zipkin. And we're going to hopefully be building more of these ones out coming soon. But this pluggable model means that, again, I won't have to change anything about my code. I can just see that tracing information here plugged into a different provider. And here's that node application as well. So this one, if I go here, this was that Python application calling the traces for that order application, both running inside the same Kubernetes cluster, which is pretty cool, actually. I think this ability to see these traces. I'm going to pause at this point. Are there any questions?
No, not yet. But well, I have a question. Like,
okay,
this distributed tracing is I think it's very cool, and it's a bit similar to a lot of functionality you see in service meshes. So how would you compare DAPR to service meshes?
Yeah, that's a great question. In fact, that's a question that we get asked most frequently. So DAPR itself is not a service mesh. It has, the important thing is that DAPR will work very well with any of the service meshes, that being Istio or Linkerd. And the service mesh, its goal is to do to provide rich capabilities for the networking layer, so that I can do calls between services, but on top of that, of course, they do things like policy-based calls. So I can do tracing like this, but I can do policies, things like 50% of my traffic goes here, and 20% of my traffic goes here. There is certainly, overlap in that DAPR does have the tracing capabilities, and it does have this ability to do direct method invocation like this. The good thing about it all is that if you want to use a service message side by side with DAPR, feel free to go ahead. We're going to be publishing a sample like that soon that shows your application using Istio as a service mesh, but you're taking advantage of DAPR for state storage. So the whole idea of DAPR is each one of its building blocks is entirely independent. If you just want to use DAPR for state storage and say, for example, a PubSub mechanism to call messages between two services, you can, and then you can use Istio for all your networking capabilities. But if you want to take advantage of DAPR's networking invocation, you can. So yes, great question. There is some overlap, but DAPR works seamlessly with all service meshes. If I move on, let me go to show you two more things to get to. I may not have a chance to do all of these demos, so I'll just talk through them a little bit. Let's talk about PubSub capabilities. DAPR has the ability to do PubSub between different services. This is publish and subscribe mechanisms. So here I can do a local subscription to particular topics that I want to subscribe to. In this particular case, I've got two applications here, a Node application and a Python application. And what we have by default is that there's a subscribe endpoint that DAPR calls onto when your application gets started, and it tells DAPR what topics it's interested in listening on. I can do the same thing inside here. There's a Python application, and it listens on two other topics here, A and C. So if I go into, I think I have another shell here. Maybe it was one here. I have a shell here. I can actually launch, DAPR run here. I can launch my Node application here and have that listening. I may have to kill. I may have to kill my other instances that are running here. What have I got running here at the moment? I've got PyCalculator running, and I got my Node subscriber. So I'm running that Node one here, and also running this Python one inside here. What I'm able to do is I can actually do PubSub requests. You can do this through the DAPR CLI. So I can actually do a DAPR publish command like this. I'm going to publish a topic A with a particular payload. This is a test. And if I run this and post this message, let me just post that again. Let me just cut and paste that a moment and post that. You see that I've used the DAPR CLI to publish a message, and both of these particular applications were subscribing onto topic A, so they could listen to them all and receive them. So you see that the Python application here and the Node application, both that are running now as DAPR applications, here they are running, received a particular event that was published to them. But if I just publish, for example, onto topic C, which is only on, I think it's on the Python application, you'll see that the Python application receives topic C here, but the Node application doesn't. So PubSub as an eventing-based model. And the key thing about this is I can plug this into anything. So for example, we plugged in this PubSub capability into Azure Functions, the functions runtime. So I can do PubSub now between two Azure functions to listen on these messages. So that's the PubSub capabilities. I think one of the most powerful capabilities of DAPR that it has is the concept of bindings. Bindings allow me to do triggers and write out to external sources based upon bindings to particular external systems. If you're familiar with Azure Functions has a concept of bindings that you can attribute on top of their function in terms of making sure your code gets triggered. Well, this is an identical concept inside DAPR, but generalized so that you can use it for, with any language on top of any environment. So in the bindings concept here, in this particular example, I can bind and define a binding using my components to a Kafka queue. So here I've created a sample topic Kafka queue, and it runs locally inside a container. And then what I'm able to do is I'm able to build an application, in this case a node application that lists on sample topic. So anytime a message that gets pushed onto the Kafka queue gets received, this particular endpoint here, this sample topic endpoint that's bound through to the sample topic name here for this particular Kafka queue gets pushed the messages into it all. So this is super powerful because now I can do event-based triggers from external systems. And so, for example, I could pull event off a Kafka queue and write it out into a DynamoDB database. And this makes it so that you can have event-based triggers around these things and make sure that you can actually have external systems call onto your system. I think this is one of the things that we've seen a lot of people start to contribute to. So if I go back to here and look at the component definition store inside here, you'll see DAPR's component store here has a concept of bindings. And inside these bindings, you can bind to a huge variety of different external things, including writing out to state stores or simple notification service or S3 inside AWS. You can bind to Google Bitbucket store or to Google's PubSub mechanism. And we're working with a lot more of the Azure bindings here. So I can do, Signal R, messages coming in from the Azure Signal R service will trigger my code, or messages from Azure Event Hubs. You'll see Event Grid appear here soon. So this bindings concept and a number of components we have here. Mark Fussell recently added a Twilio binding. So here, SMS messages sent to your Twilio endpoint can trigger a particular piece of code inside your application. So this is super powerful around this sort of thing. It's something that we've seen that people take a lot of advantage of when they build their applications. Let me return back to slides because I think I've done quite a lot of what I'm going to talk about in slides in terms of method invocation between services, the concept of PubSub, where one service can publish and subscribe through different PubSub mechanisms. This example is Redis, but it could be Event Grid, or it could be Event Hub, or any number of different pluggable PubSub services. We've seen the distributed tracing with OpenCensus in terms of pushing different providers into this, including Zipkin and Prometheus and others. And I showed you the distributed calculator demo in terms of how you could do calls between them all. And then we talked about triggers. I showed you triggers from external systems into my app. For example, I have my DAPR hooks up my trigger endpoint here that calls into my app, and equally I can do output triggers here where my application can write out data to an output binding here called my database, and then I can hook that up into any one of these pluggable models and switch these all out. So just like you saw me switch a state store, I don't have to change my code if I wanted to switch my external binding output from pushing messages into a Kafka queue as opposed to Twilio, which makes it very portable across different platforms. And that's one of the keys around to DAPR's capabilities. It's the ability to integrate with existing systems and its portability across different environments, and without you having to change your code. Let me dive into sort of my last little bit of a topic here, and then we'll have time for some more questions. Actors, if you're familiar with them, is a powerful way of building certain types of applications. And in this case, we decided to bring all the actor capabilities, particularly from Service Fabric, if you're familiar with that. If you're familiar with Orleans, it's a similar concept as virtual actors. A virtual actor is something that is garbage collected, has a unique ID, it comes into existence, lives for a certain time, and then persists its state. And actors are very useful because they have code and state co-located, and they have a single thread of concurrency as well, so you don't have to deal with concurrency issues. If I have 5 methods on my actor, and one is called, the other calls onto the actor get blocked until the first call is completed, so you don't end up with concurrency issues on the state that you haul inside your actor. Actors are tiny little objects. You can have millions of them. Yeah, if they all die on a particular node, they get activated onto another machine like this. And just as you'd expect with DAPR, we've effectively built a standard around this now. So, instead of having fixed binaries or APIs that you have to pull in, we have an endpoint here that you can call in order to invoke actor of a particular type here called myActors and call particular methods on it. So the placement service does the job of figuring out where to place a service, or place the actor, I should say. And so if you want to invoke a particular actor, in this case, actor with a particular ID here called ID A, and invoke the update method and send the data to it all, that may be on one machine. But if I want to invoke an actor of a method of instance C onto a different machine and call its update method, that may be running elsewhere. So DAPR takes care of routing all the messages between the hundreds of thousands of actor instances that may be running in different pods inside your Kubernetes cluster, and calling the actual endpoints onto those, in this case, the update endpoints. So this sort of standardization now allows you to have actors call across different languages. So I can call a Java actor onto a Python actor, and I can just do a simple curl. If I want to do is just get back the actor state. The actor state itself is under a consistent format. So however it gets stored into your, again, pluggable state stores, I can plug into them all. So I can plug in a Redis state store or Cosmos DB state store. You'll see that that state is consistent between them all. And in order to make actors usable from, or more friendly, I should say, from the different language providers, the key is, although I've shown you a lot of different HTTP calls recently, there are actually first-class language libraries built on top of DAPR that, as a developer, you can choose to use. These are the ones we have today in terms of Go, Node, Python, C#. And we're sort of building these ones out so that, if you don't want to simply do HTTP or gRPC calls and you want to sit at a typed language level, you can. And then, in particular, both our C# and our Java ones, we've put in first-class actor capabilities into those, and we're going to build out actor capabilities into all the others. So you'll have Go actors and Node actors and Python actors and Rust actors, and C++ and Fortran and COBOL and Akka and whatever other languages you want to have as part of all of this. So just kind of give you an idea of what this looks like from one of those language perspectives. Yeah, we did this first with C# just because we brought a lot of the code over from Service Fabric, if you're familiar with that. But in the concept of an actor, these actors, and this is showing you now the C# SDK that not only has actors inside it all, but all the other methods that you saw. So instead of using a state URL, I can call a state client in order to save state with a C# language syntax, if I prefer to do it that way, rather than having you to kind of build out a URL call. So if you're familiar with Service Fabric actors, this is literally identical. In fact, all you have to do is literally change Service Fabric here, actors for DAPR actors, and your code will compile and run. So that's really the only change you actually have to do. But actors are defined by an interface with a set of methods inside them all, like this in terms of get data and save data. You then implement the interface. So in this particular case, I implement the iDemo actor interface with actor, and I write my code here. So I write my save data method, which saves data, and I write my get data method. And you'll see that here you have the state manager capability that does the abstraction about where my state gets saved. Just like we saw the pluggable component model for saving the state from the Python application, this is pluggable forever I save it all. And now, in order to use this, I can actually use this from a client. So before I run the client, what I'm going to do is let me use DAPR here. So I've built this project. I'm using the DAPR CLI here again. This time I'm going to do a .NET run on the project. I'm going to run the demo actor application inside here. So in the same way that you saw me launch Python applications and Node applications, I'm now launching a .NET application here that's listening on Actor, that has an Actor SDK inside it all. And if I just go off here and do DAPR list, you should see now that I've got, oh, I should go to kill my Node applications running. So let me just kill off these a moment because they will get in the way there around these things. So let me just check that I don't have, there we are, I just have my demo actor running again. In fact, I think I need to go back and probably relaunch this because there's a port clash between them all. So there we go. I'm running my .NET application here. So to use this, super simple to use. I can simply new an actor up with a particular value here, and then I can start calling methods inside it. So I'm just going to run this inside the debugger because I think it's a good way of helping you see how this runs. This should hopefully attach to all of this. You see inside here, I can just sort of single step through here, and you'll see that if I continue and let this run, I will call on to the create a proxy method that will call onto my actor state. Hopefully you can just about see this inside here. You can see that I called the get data method inside here and returned the data that's running inside the actor. In fact, I called a save data method and the get data method. So inside here, you see that I simply created a actor proxy inside here. I called the save data method here in order to save data, and I called the get data method inside here. So this was extremely easy for me to use. I can actually go off and even look inside my Redis state store if I'm lucky. And inside my Redis state store, you'll see here's my demo actor state that just got saved for my actor instance. So this is an actor instance, and this is a sort of this is a .NET serialization format at the moment, but you can change the serialization of what this looks like. So I can retrieve serialized state into other languages if I want to. So we just have to use the .NET serializer for now. But the key thing about this and what makes it so cool is that actually I can go off and I can do things like I can do a curl on this particular. I go back to open up a browser window inside here. And let me do it inside this terminal. I can do a curl method here on my demo actor, and I can save some state inside here. So I can say, go off and save the state inside my actor, and then actually can go and say, I can call onto this endpoint. I can do get data like this, and I can retrieve those data I just saved. So being able to curl or HTTP endpoint of my actor methods that are running, is super flexible because I can, maybe this is all I need to do from another language in order to retrieve the data and state that's been saved by my C# actor. So now makes it kind of a lot more open and flexible and capable from different platforms. So I'm kind of near the end here. That was actors. We have a very vibrant community at the moment. We've had lots of contributors. Please come and join our community. We have calls every 2 weeks. We're having a call next Tuesday, and we have lots and lots of demos inside them all. We've seen a huge number of people kind of jump on and kind of star our GitHub repo and give us contributions. So please come and join the community calls. And as we look forward, our roadmap is very much around building out these language SDKs, providing great diagnostic support, integrating with other frameworks. I didn't show you the integration with ASP.NET Core, but we also can integrate with functions runtime and Blazor backend runtimes and Django and things like this, and then across different platforms, as well as on the road to getting this production ready to run in your services. So with that, we've got a chance for a couple more questions, and I'll hand it back over to see what people have to ask.
Yeah, let's open up for questions. So if anyone has any questions, please let them know on the chat. I will check them. I have some questions already. So Mark. My colleague Luke asks, is DAPR going to be the successor of Service Fabric, looking at actors and those kind of things, or should we still be able to, should we still start new projects with Service Fabric, or should we then choose DAPR?
Oh, no. Okay, so that's a good question. Just to be clear, DAPR was all about extending the programming model capabilities that you had inside Service Fabric and other platforms. So that's what it focuses on. When we started to launch, and people came along to Service Fabric and said, wonderful set of programming languages, but I have to consume all of Service Fabric. Why can't I use and have all the wonderful capabilities of Service Fabric actor model in other languages? So that's really what it's gone and done. It's empowered developers to run on different platforms. That doesn't mean to say you should take away from Service Fabric, because it has great other great capabilities built into it all, notably, a very resilient, scalable clustering technology. It has, it's failover. It's how we build all our services at Microsoft. So yes, you should fully go ahead and build new platforms on top of Service Fabric if that's what you want to do. It also has an active programming model built into it all. We will make sure that DAPR will run on Service Fabric. It's going to be a target platform, so you'll be able to do the best of both worlds and that have DAPR running on top of Service Fabric as much as it has on any other platforms. So yes, Service Fabric is just as good as any other platform if that's your choice of how you want to run your service. But we recognize that other people also want to use Kubernetes and Swarm and other platforms as well.
Okay, another question is, looking at the actors, what I was really missing there is the DAPR says it's an event-driven library, and the actors really are missing some event-driven capabilities there.
Yes. So you're asking, why don't I have PubSub between my actors?
Yeah.
Yes. And the answer is it's coming. Yes.
Okay.
The answer is in the next release that we do of the SDK, which will be our 0.5 release that will focus around March timeframe. You'll see actor PubSub capabilities. There's actually in the repo, in fact, in the repo, there's an open issue on that. So if you actually go into DAPR, and if you actually go into
I looked at that last week. We gave it thumbs up. So
yes, that's coming next. That's next. Very frequently asked question. So yes, it's in the issues list here. Yes, it's one of the ones inside here.
Yes. So could you? You talked about the bindings as well. Is it possible to connect those bindings to actors as well, or not?
That's another thing that you can't do just yet. But again, it's a great piece of feedback. Can I have an actor binding trigger my actor? No, not yet. But
it's quite similar to the PubSub, I guess. So it's
yes. That's also a great ask as well. Yes, in fact, having an actor triggered from a Kafka queue would be another great piece of integration. I don't know if we're going to be doing that one next, but that would certainly be on the roadmap as well. Yes.
Yeah, I think having the PubSub first, that's one of the major issues for me. And also, I think a lot of people are coming from other actor frameworks like aka.net or those kind of things. And that's in those kind of frameworks, PubSub is really at the heart of the framework as well. So
correct. Totally agree.
When they open DAPR actors for the first time, they kind of miss that kind of feeling.
The great thing is that this entire project is open sourced. Yes. So
yeah, sure.
There is nothing preventing you. In fact, we will greatly encourage anyone who wants to kind of come in and contribute code on any one of these frameworks. Whether it's a .NET framework or the Rust framework or the Node framework, and put in, want to build those capabilities. So, it's you don't have to really wait on anyone, but we are, slowly getting through the priority asks ourselves. Yes, PubSub is one of those.
And it's good to at least ask you now. If you say it will be there in the next release, it's not something that I would start building myself. If you said, well, we're not focusing on this, then it might be something that we could pick up ourselves. So
yes, here's the one. So thumbs up this. And we're driven a lot by these things as well. So if you vote these things up, that's how we look at these things.
Okay, I think we're out of questions. So let's wrap up this call. Thanks everyone for watching. Thank you, Mark, for this great session. Really insightful stuff. I've played around with it myself since the very first week. I really like the technology. And what I really like is all the demos, etc. They all just work when you try it themselves. Often when you try these new 0.1 releases, then it's really hard to get stuff up and running. And well, for me, it felt really stable, the stuff that was already there. So that's really thumbs up for you and your team.
Thank you. Yes, and I mean, and we're pretty fanatical about if you launch Gitter, we have a big community of asking questions inside Gitter. If you go to Gitter/DAPR, then please reach out to us there. Reach out to us on Gitter. Reach out to us on community calls. And if you're building a project with DAPR, we're more than happy to help you. And you're taking it to production, we're more than happy to help you write the code, or help you review your code, I should say, and get you on production. We're doing this with several customers at the moment because we realize that the success of DAPR requires us to have high-scale, highly available production workloads running in production.
Mm-hmm. Okay, great stuff. Well, thanks again, Mark. We're going to end the stream. Next week we'll be back. Next week we have Mark Dijker, a Microsoft MVP from the Netherlands, who will do a session on Azure Durable Functions. So that will be a great session as well. Hope to see you there, and or at some other event. See you later. Bye bye.